Okay, this is the last session of the day. And I just want to go a little more into technical detail of what happens when you want to submit to the grid. And again, this is all behind the scenes. So if you use glide and something like that, you probably never exposed to it. But this is an OSG school, so you should know also the things you will never actually need, possibly. But likely you will. So you never know. So, OK, this is the usual summary of what we did until now. And a few more words about Open Science Grid. So you maybe already know by now that OSG is really an umbrella organization. OSG does not write any software and doesn't own any hardware, at least to the first degree. Everything that you use in OSG comes from somebody else. It's not the OSG itself that provides either the software or the hardware. OSG just makes sure that various providers come together in a uniform way so that it is possible to use this large amount of disparate users in a relatively uniform way. So what OSG does do is provide some standards so that people agree on. One of those is X509 VOMs. As I said, there are many options for single sign-on, and OSG essentially negotiated that this is what would be used for anybody that is part of Open Science Grid. They standardized on the Globus GT2 for the Grid C technology, although we are trying to move from it because it's effectively deprecated, and we are looking what to do next. Although it's likely to be in production for years to come, but we would like to move slowly away from it. And it also provides a standard software distribution. Again, nothing that OSG has written itself, but just a collection of everything that anybody in OSG might need. It's brought together into a single package and distributed to all the users that are interested. It is called the Virtual Data Toolkit, VDT. You probably heard about it, and Alan is leading that area. But again, it's not something that OSG has written. It's just packaging activity, like you would think about Red Hat, although they do write some software. But mostly, they are packaging together stuff developed by somebody else. OSG also runs some services that are of use to the larger community that no single user could really do. One is a troubleshooting service. It's called the Grid Operations Center, or GOC. And this is a common infrastructure that essentially knows about everybody else, so that if you go to them with a problem, there is a large success. They are likely to know who to contact to fix the problem. They run information services. I'll have a word about that a little bit on. There are accounting services that essentially allow the VO management and users to know how much was used by whom. So that when you ask, well, how many cycles did I actually provide to LIGO this month, and I am a CMS site, I can check. I know I have I should be able to deliver 10 million hours of CPU in a month. Did I? This kind of stuff. And it also provides a gliding factory so that users don't need to deploy their own. They just need to deploy the VO-specific part. And the factory, which is the thing that talks to the grid, it's actually centralized, so users are shielded from the grid as much as possible, if they want to use glidance, of course. You're not required to. So a word about what is in my opinion, this is completely my personal opinion, what is the easiest way to get going on the grid? By far, the easiest way is joining an existing, well-engaged VO that has been using the grid for a while. If you are part of CMS or Atlas, you don't have to think. Do whatever the VO tells you to do, and you are very likely that things will just work. They have the staff that has been looking at the grid problems all along, You don't need to think about it. Second easiest thing, if you cannot do that, and I suppose quite a bit of you cannot do that, is to get going with an overlay pool, possibly the glidings, and talk to the OSG-provided gliding factory. This way, most of the grid is hidden from you. Not all of it, but a large fraction of it is hidden from you. And all the grid bad things are being taken care by the factory administrators behind the scenes without you ever noticing. And then, if neither of this is an option or you don't like it, there is always the direct submission part. You've seen this morning, it can be painful, but sometimes it's just the only way forward. And you are always welcome to do it for whatever reason you want. Now, usual cartoon, are we done for today? So if I was a scientist, I would actually do this. I would say, why the heck are you wasting my time? You tell me, go with the glidings, everything is just nice. Why should I care to do everything else, anything else? Do you agree? Disagree? Yes, no, yeah? Good. Because I agree too. So as a scientist, this is exactly what you should do. You should take the path of least resistance. Your goal in life is to science. Computing, it's just a tool. And if it doesn't work, it's just getting in the way. So yes, you should do as little CS as possible if you are not a CS scientist. But the IT person in me tells me also that that's just too idealized. If you don't know what you're doing, you are likely to screw up. And when you screw up, this guy is the one responsible to fixing you after you. So knowing what you are doing, it's still a good idea. So a few words about using OSG directly. You actually have done more than I thought you would be doing this morning about this. But let's still, the slides were written before you did the exercise this morning, so I'll go through all of them. So some basics on using OSG directly is use Condor G as much as possible. Globus tools that allow you to talk directly to the Globus-based CEs simply don't scale. Try to use them too much, you will be banned for life from the grid, because you will do a lot of damage. Know how to discover which site supports you. And yeah?
Did we use any Globus?
No, but we'll have some exercises later on, just to show you that they exist. But in all your examples, you used Condor G, and for a reason. More questions? No? OK. So the second thing is know which sites to use. This morning, I told you which sites to use. In real life, you will have to discover it yourself if you go it directly. As I said, if you are part of a VO or a big VO or you use glidings, it's not your problem. But if you do it all yourself, you need to know this. Because not everybody will let you in. So you need to know which sites on the grid are good, which sites are bad. And so that's important. And you need to know what to do if something goes wrong, because you had your share of wrong this morning, so I don't think I have to convince you that as soon as you have a distributed system, something will go wrong from time to time, actually quite often. So you need to know how to live with it. So you've seen this morning, and essentially how you use the grid. When you use Condor G, you just say universe is globus, but then you have to specify the grid resource. So in OSG, you always use the GT2 technology, which tells talk to the CE using the globus protocol. Then you tell it which node to talk to. Essentially, this is the real IP address of the machine. And then you have to specify which local HTC you want to use. There are more things that you can tell Condor G and through Condor G to Globus, but we will not go into them. I think it's more advanced that you want to know. Although if you ever want to do something advanced, you will probably need to know, but not today. So the final part, the job manager. What the heck is the job manager condor, and why should I care? Unfortunately, you have to care because by default, if you don't specify any job manager, Globus, if you just specify the node, Globus will use the job manager fork. And job manager fork essentially tells the gatekeeper, the CE, run your job on the CE. It will not forward it, for example, to Condor to run on worker node. It will always run on the CE. So you can imagine that running 10,000 jobs on the CE is not a good idea. But that's exactly what Globus will do if you don't tell it anything else. So you need to specify the right job manager, for example, job manager Condor, job manager PBS, like you had in the examples, to actually get it into the real batch system that is behind the CE. And it's unfortunate that it's not automatic, but that's life. And you have to live with it. So now that you, yes?
So you have to specify the
job manager something.
manager when you submit it.
Yeah. And if you look in the exercise this morning, you had it. So now that you know how to submit, you need to know where to submit. And unless somebody tells you explicitly, like in an exercise, copy and paste, you have to discover it. My advice is start with your friends. Find a few sites that you know administrators of. Start with them. They will tell you how to submit to their site. And if you have any problems, they will help you debug it. As you've seen, the grid is pretty much a black box. Something goes wrong on the other side. You sit on the other side wondering why it didn't work. So having somebody on the other side that you know, that you trust, that is willing to help is great. Of course, you can only do this for a few sites, unless you are a really popular person and everybody knows you, but I don't know how many of you are like that. So you will need to discover it. And to discover the sites, you need some sort of information system, right? And in OSG, this is the so-called BDII information system. BDII, it's an LDAP-based server. If you want to know what LDAP is, just look up on the wiki. It's pretty standard. But LDAP is very generic. You can throw anything you want in it. So you need a schema that describes the semantics of what you throw into it. And OSG has defined a schema, well, not alone, but it's using the schema called the glue schema that defines the semantics of each and every attribute that is in BDII. It's a very long document. You're welcome to read it, but don't feel compelled to do it because it's really long. But the real only things that you are, or most important things that you are interested in is how do I get to that node, and maybe a few side descriptions like which VOs it supports, how big it is, and stuff like that. There is way more than you want to know through all the glue schema, and not all that information that is advertised it's correct. Because sites tend to configure the important information, and everything else is just garbage because nobody uses it and nobody complains. That's life. Things that are not exercised, but they are still required, just become garbage. And that has happened to a lot of the information system. So this is about how you use the grid. And we have a few more exercises after this that you can try out and get a little bit of what I described. But I want to go quickly over the job errors you can get. And you have hit a large fraction of this already this morning, so I'm not too worried that you don't believe me. So the five most common errors that you see are the authentication and authorization problems, jobs that never start, jobs that fail without any output coming back, wrong OS when you land on the worker node, and the missing libraries. But this is just a partial list. So many other things can go wrong that I will not even try to list them all. I have seen probably hundreds of failure modes, some fairly rare, but when they happen, you just bang your head against the wall because it's completely crazy. Doesn't happen too often, likely, but it does happen. So let's start with authentication errors. As we said, you need to present something to the site so that they will know who you are, and then the site needs to decide that they are willing to let you in. And when you try to go to a site and you get the famous Globus error 7, you are not authorized, several things could be reason for that. The site may not be interested to supporting you. You are trying to go to a site that clearly has no intention to supporting you. So sort of your problem. The site may think it supports you, but it's really misconfigured. So from your point of view, nothing changes, but they are definitely convinced that you should be able to get in. But it may be just your problem. Your proxy just expired, right? Or certificate expired. Everything has a lifetime in the security world because of the risk management. So it could be just your problem, effectively. And it's extremely difficult to debug because 101 of security says if authentication or authorization doesn't succeed, tell them to go away and don't tell them why. The reason is because if the person trying to do that was somebody that really wanted to hurt you, telling him why will help them hurt you. So you try to hide as many information as you can from them. If you are a legitimate user trying to do that, well, they don't know. They still treat you as a real threat and will just send you away without telling you anything. So just you know why the security messages usually are so damn obscure. It's 101 of security. And you may argue it's a good thing or not, but pretty much everybody in the security community agrees it should be that way. Another common problem of when you run over the grid is that a job may never start, right? You submit to Condor G delegates it to the other side, and your job sits in the idle state forever. Why? It may be perfectly legitimate. The site may be used by many users. You have a very low priority. You're just waiting. You haven't paid for it. There's no guarantee you will start in any reasonable time. And this is actually unfortunately, quite usual in the opportunistic world when you try to use as many sites as possible. And some sites will give you a slot every 3 days. So in 3 days, waiting in queue 3 days, it's a long time, right? Everybody will agree. But if you are trying to get something done in a month, getting a few slots here and there over 3 days on 100 sites, it's still something, right? It will get you faster, especially if you don't have a dedicated cluster and you are purely opportunistic. But it could be a site problem. The site may be misconfigured. So as some of you have found that even your vanilla universe job hasn't started because you forget transfer executable equal true, the site may do that mistake. And you will never know because you don't know what happens on the site. That is completely black box to you. All you have to is your Condor queue locally on the Condor G side. And if they misconfigure on the other side, well, good luck with that. Or you may hit a bug where the C actually forgets about your job. Haven't seen that. Have seen that. And it's unfortunately less infrequent than you would think. They just forget. Yeah, it should not, but it happens. The next common problem is you submit a bunch of jobs, great, they run, they finish, you get no output back. Why? The most typical cause is the black hole effect. Essentially, you have a worker node that's misconfigured. It starts your job, kills it immediately. Gets the next job, kill it immediately. Next one, kill it immediately. And of course, because the job was killed immediately, no output is coming back. But the grid interface completely has hidden this, and you just get a completed job with no output. And you stare there, wondering what the heck is going on. And unfortunately, it's sort of difficult to find it out for the site administrators because they don't run the jobs. They just allow others to come in and know If the node fails in a creative enough way, it's pretty much impossible to detect, apart from maybe monitoring how many jobs it churned in a minute. That's actually a good thing. And from your point of view, if you think that the grid has something like, I don't know, 10,000 nodes, what do you think is the probability that at least one is broken? Pretty high. So you will see this more often than you would want to know if you submit directly to the grid. Luckily, if you use the pilots, the overlay system, this reduces the problem by a lot, because the pilot will get on the worker node and get killed. So the job will never get there. So your jobs will only run on good nodes. And having some pilots eaten by black hole, yeah, that node will have zero utilization, but that's a side problem. It's not your problem. So you don't care too much. So it's, at least we have a cure for it, if you're not able to eliminate it at all. Other problem is the wrong OS. So you may compile something for Red Linux 5, but your executable starts on Windows. What do you think will happen? Nothing good, right? So it could be just easily your fault, because the site clearly stated, we only support Windows machines, and you said, I don't care, I submit it anyhow. That's your problem. Good. You will probably not get many Windows machines on Open Science Grid, but you could get some Ubuntu versus Red Hat 5, and now people are moving to Red Hat 6, and maybe you have a Red Hat 6 executable that may run on a couple of sites, but will fail in 95% of Open Science Grid, so you have to be careful. But it can be a real site problem, because I have seen it happen that sites, by mistake, reinstall a set of the worker node with the wrong operating system. For example, it happened about a year ago. One site had just moved from Scientific Linux 4 to Scientific 5 since a month or so, and they have a few nodes failing their disks, and when they bring them up, of course, they had still the old configuration. So they started with Scientific Linux 4. So all Scientific 5 applications failed there. So it may be a real site problem. It's not always your fault. And again, the pilots can sort of help here, either because the pilots themselves fail, because it is not the platform they expected, or at least you can test what you landed on. And since you are, or your VO is in charge of the pilot, it doesn't depend on the 100 sites doing all the right thing. You at least have yourself to blame if something goes wrong, which can be good or bad, but at least you have some control. And finally, there are the missing libraries or files. Most real-life applications need more than just a simple executable. They may need system libraries. They may need the BLAST database pre-installed. They may need support scripts that have been pre-installed. Usually, you will have a lot of files that you need. So if you are not bringing them all together with you, something may go wrong. So you could argue that the best approach is bringing everything with you, but sometimes it's just not practical. If you have to transfer a few gigs of files every time you launch a job, you will run out of network capacity very fast. So sometimes you just have to rely on the fact that something is pre-installed. But how do you know that actually is pre-installed there? So you just have to essentially make an educated guess. And this may be especially problematic the first time you use the site. So you may need to send a few jobs just to probe what is there, and then install whatever is missing, send more test jobs, submit some more. But it can be also a problem if you stop using a site for a while and come back. There's no guarantee that from yesterday they haven't removed any files or installed the node. So if you are relying on something being pre-installed on the worker nodes, this can be tricky. And again, pilots can help a little bit because at least you can test in the pilot itself if all the files that your applications will need are there, and fail the file so that the user job will never get there. So you may be wasting resources because you are not using a worker node, but at least from the user point of view, he will not see any failures. And the final user human time is usually the most expensive of them all. So you really want to minimize the pain, the wasted time the real scientists are wasting. And finally, as I said, once you find all the problems and you start to understand them, you need to know how to fix them. And most of the grid errors cannot be fixed by you. Apart from renewing your proxy or putting the right requirements expression, most of the problems are really site problems, and you need site admin help. And given that you have of the order of 100 sites to deal with, it is unlikely that you know who to contact at each and every site, and it's even less likely that the sites will read your email if you just send it directly. So for this purpose, OpenScience Grid has the Grid Operation Center, which is essentially a clearing board of messages. So you open a ticket with them, they will know who to relay it to. They will put some pressure behind it. Find people, experts, if the site itself doesn't know how to solve it, and so on. So that's the best approach when you have a problem. And that's all. Effectively, all I have as lectures for today. There are some exercises that are follow-up to this for today. We have a good half an hour. Well, no. We have a good 15 minutes to finish the exercises. We can go past 5 o'clock if you want, and there is always the 7 o'clock evening session if you're interested. So switch to the yeah, let me close here and start the exercise.